Electron configuration core for anything except for a noble gas. Only the things that are at the end of the periodic table. Okay, would you try one? How about if I give you, would you write the electron configuration? You can write it the short way. Sometimes in my Chem 1 I'll ask them to write the whole thing just so they get used to where things are. Europium. Can you find it? It's right there. EU. Ah, well, why not?
That's me.
Write it the short way. Don't start with one S, please.
Why not?
I don't like this periodic table much for this reason. Are any of you kind of struggling with this, looking at the atomic numbers?
There's no thing.
It's really far.
It goes no.
Yeah, after 6s, which is right here, 6s1, 6s2. So barium is the end of 6s2. Look at the atomic numbers. Then we go to La, 57. And then after 57, we come down here. So what is this? Is this a 5D or is it a 4F?
Is it 5D? Is it a 5D?
It is 5D.
So you do 5D1?
Yeah, but then what? What's that one then?
5D2.
5D1, 4F1?
Is that? I'm so confused.
Yeah, I know. That's why I don't like that periodic table. All right, here's the truth. Now, I'm going to tell you what the truth is, but you don't need to know it, and please don't try to study it or remember it. It is true that if you look up the electron configuration of lanthanum and actinium underneath it, they are actually going to end with D electrons. But then after those, we come down here, and they start filling up F electrons. This is weird. So this is 6s, and then lanthanum ends with 5d, and then Ce, cerium, ends with 4f1, 5d1, or 5d1 and then 4f1. So it's got 1 in the D and 1 in the F. And then praseodymium will end with 4f3. So it forgets that D electron and just sticks it into the F. Very exceptional. It's like all these exceptions. Please do not try to memorize all the exceptions. Here's what I want you to do. And that's why I think they've pulled all the F's out of the AP curriculum. I don't even think they expect you to know this. But honestly, I don't trust the College Board people. I think they tell us, oh, you don't have to worry about F's, but then they might put F's on the exam. And they've done dumb stuff like that before, and so I just don't trust that if they tell us something's not going to be in on the exam, that it really won't be.
Yeah, what's the market revolution? Oh, it's like a push. They put like an essay question that was not.
Yeah, they do that stuff.
And it was like a whole essay question.
Yeah.
So.
It's very frustrating. There's something wrong with it. Yeah. And you have to pay them. That's a drag. Anyway, so here's what I want you to do. I want you to assume, and with this periodic table it's a pain, but I want you to assume that La and AC are really down here. So when you go to europium, you'd say 6s2, 4f, 1, 2, 3, 4, 5, 6, 7. It would be 4f7. Now, if you said 6s2, 4f6, I would understand. I'm not going to mark you wrong, because it's very confusing. I know. This periodic table actually gives you the electron configuration. It's written on here. That's how I knew what the electron configurations of these are. I don't remember. I mean, the ones up to XE, yeah, we have to know those. But these, with all these exceptions, I don't know what they are. This is why Lauren and Emily chose to sit up here in the front all year. They have not budged from their seats, not because they want to suck up to the teacher, not because they can see better or pay attention better. They can cheat.
Yeah.
I can see it though.
Yeah, that's what she says. So you got some love over here. Okay, so anyway, europium is going to be Xe, and then 6s2. What did we decide it was now? 4f7, right?
Yeah.
How many unpaired electrons in europium?
7.
One. No, one. No, wait, no, it's 9. Oh, okay, wait. F has 5, right? No.
5. Or no, 6.
Matt?
7.
7 it is. Why did you say that before?
It's 7. Oh.
It's 7, yeah.
7.
Oh, yeah.
4f has room for 14 electrons. There are 7 lines in 4f. So we have 1 electron on each line. There'd be 7 unpaired electrons in that element. Yes? You need to see that, or do you understand what I'm saying? Matt?
How can we go to 4 for F?
F's are high enough in energy that they overlap the S that's 2 levels above. So the D's will overlap the next energy level's S and be higher than. The F's are so high in energy that they'll be higher than the S that's 2 energy levels above. So in the 4th energy level, there's 4S and 4P, 4D and 4F. 4D is higher than 5S because they'll be overlapping the next energy level. 4F overlaps and is higher than 6S. So when you're in the 6th row of the periodic table, you have 6S on the left and 6P on the right, because the S's and P's are always the same as the row number. However, in the middle, in between those two, after 6S, you have 4F, and then back up here to 5D, because the D's are always 1 less than the row number. That's that. Electron configuration. Yes?
How come they don't include the D for that, one, the D they have like that?
Well, we only have, lanthanum was only a D. This electron that shows up here was only a D for a couple of elements. After that, somehow it changes to Fs.
So it becomes an F?
Yes. Would you try these 2 electron configurations? Just write it the short way. But no, I was just thinking. I was recording this. I was recording this for Amber, and I thought maybe I should show Amber her shamrock so she can see it before she gets back to school.
So if someone else looks at it, watches the video too, we kind
Who is going to watch it?
of their fans.
Somebody that has no life, guaranteed.
What? I don't know why.
You don't go back and watch these, do you? No way.
I watched this computer jokes again.
So just
Yeah, the
talk about
intros we actually.
Yeah.
Just the intro and the end.
Is that what you watched?
No, I don't watch it.
No, I don't watch it.
Okay, so do we have 2 electron configurations? Bromine should be really easy. You're still counting, sorry. I'll put the bromine one up here. You're not going to get this one wrong, though.
Or beat it. Beat it.
You won't. Yes, I would. Oops, I'm going to get it wrong. Okay then. Then gold. Gold is going to be atomic number 79. So the noble gas that comes before it is xenon. And then we start the 6th row, and this is where the fun begins. 6s2, that part was easy. And then we're going to go to 4f. There's 14 electrons we know for sure in 4f. Okay, now what do we do from here? After barium, I'm going to count lanthanum down here. So we'll go 14 electrons, and then that takes us right here to Lu. The electron configuration of Lu would have xenon, 6s2, 4f14, and then 5d1. So this has the last electron in 5d, and this has the last electron.
So the Lu is D.
But this one has the 14 4f's in there before the 5d. Have I lost you?
Yes.
Dumb. I hate it. Sorry. So this is going to be 5d1, I guess is the point. That's 5d1. And we come back up here, 5d2. I didn't go there because that one was already counted down here. 5d2, 3, 4, 5, 6, 7, 8, 9.
Why don't I just
You
move
just
it around?
replace it.
Yeah. I know. That's why I don't like this periodic table. I think LA should be down there and LU should be up there.
Yeah.
Or, like in the other room, in room 302, these 2 spots are blank. LA and AC are down here. And those are nothing. They're blank spaces. I mean, there's something in there. It says like 57 to 71. So you know that LU and LR really go back up there and start. So the point is that we have 4F14, 5D9. Did you come up with that? I count them all.
What do they use xenon?
Sorry. What?
What do they use xenon?
I'm trying to think of anything I've ever heard of xenon being used in. They do use xenon in research to try to get xenon to bond to things, even though it's a noble gas. And it does. That you can make compounds with xenon. But I don't know what they're used, if anything, for. And I can't think of any other use of xenon. They use argon sometimes. Argon makes up a bit of our atmosphere. It's about 1% of our atmosphere is argon. And so when they build windows, usually our home windows have actually 2 panes of glass in them. And in the middle of those 2 panes of glass, they try to suck all the air out and use argon in between the 2 for the thermal insulation. And supposedly that's helpful. I don't know why. Okay, so just one other thing that I wanted to say. Do I have time to say it? Yeah. If we need to write the electron configuration of ions, what does that -2 up there mean after the S? There's 2 more electrons in it. Right. So the electron configuration of the sulfite ion, we would have the 16 sulfur electrons plus 2. So it would be, and I'll just use the shorthand one, neon core, 3s2. Now, neutral sulfur would be 3p4 at the end, but since this has another 2 electrons, it would be 3p6. So you just have to add the 2 electrons. And normally for the anions, it'll just take you right to a noble gas.
Wait, what if it's like... What if it goes past the noble gas?
It won't.
Oh, yeah, no.
Because the noble gas, like I say, is the anchor. And once an electron configuration lands on a noble gas, there's no reason for it to change. It's the most stable. We good? Okay. Now, here is the part that I wanted to make sure that you saw. Fe plus 2. Now, this is going to be the opposite. Instead of adding electrons, we have to take them away. And I know what you would think you should write for the electron configuration, but you'd be wrong. And I'll show you what we're thinking. So iron, when we do neutral iron, it has the electron configuration. In fact, I'll do this. Fe has the electron configuration argon core, 4s2, 3d6. That's neutral iron. If we need a positive 2 iron, we have to take 2 electrons away. And naturally, you would assume that the 2 3d electrons come off and it would end with 3d4. That's not what happens. When transition metals form ions, they have to lose electrons because metals always lose electrons when they form ions. Take away the s electrons first. I can't tell you why. I don't know why.
That's corrupt.
But we know that the first electrons that come off are going to, for the transition metals, are going to be the s electrons. So you need to remember that. So Fe plus 2 would be argon core 3d6.